I believe that the frustum, that is the shape of the tank, was obtained after part of the cone was cut off. And this is a shape that we call or we refer to as a frustum. So this is the shape of the cone which was cut off, and the dotted part represents the part that was cut off. And we do not have, since we don't have a direct formula to get the surface area of a frustum, we must consider the part that was cut off so as to be able to get the surface area. The surface area of a cone is equals to pi r L. Let that let the big radius, that is the radius of the big cone, be capital R, and this is R, and the small cone represented by small r. Let L represent the slanting side of the big cone, and L represent the slanting side of the small cone. So it means the surface area of the frustum is the surface area of the whole cone minus the surface area of the small cone. So it is pi RL minus pi RL. I hope that is very clear. But remember, we do not have the length of the slanting side of the big cone and the small cone. So how do we do that? We are going to use a big radius and small radius to calculate the slanting sides. So let the height of the small cone be represented by a small h, and therefore using the linear scale factor you find that the ratio of the radius is equals to the ratio of the height, because the small cone and the big cone are similar, and therefore we say the height of the big cone will be 7.2 plus h, so it is 7.2 plus h divided by the height of the small cone is h, is equals to the radius of the big cone is 12 divided by the radius of the small cone is 6. So here you can compute, and you will be able to get 6 multiplied by 7.2 plus h is equals to, that is you cross multiply, is equals to 12h. Then you open the bracket, you get this is you multiply, you get 6 times 7.2, you get 43.2, then plus 6h is equals to 12h. Take 6 to the other side, you get 6h is equals to 43.2. Divide both sides by 6. By 6, you get the height of the small cone h is equals to 7.2. 7.2. Now, with the height of the small cone, we will be able to get the slanting side, because now we get the ratio of formed, that is a triangle. We say this is a triangle. This is the top, so this is the top. So this we say it is 12. Here it is 6. So we can use this now. We have gotten the height of the big cone is 14.4, and therefore we can get now the small l. We get L is equals to 7.2 squared plus 6 squared. So that is using the Pythagoras theorem. So our small l is equals to 9.37, and our big R is equals to the square root, that is something side of the big cone, 14.4 squared plus 12 squared, and this should give you, using a calculator, you get it is 18.74. Now with that, we can now since now we have a small r, that is a small r, the big R, we can now apply our formula here to get the surface area of the frustum. This means that the surface area of the frustum is equals to, we can factor out pi, and we are left with RL, that is capital R, capital R, minus small r minus small r, small l, which is equals to, this is 22/7 into bracket. The big R is 12 multiplied by 18.14. This you minus the small r is 6 multiplied by 9 point, that is we get it is 9.37, and when you compute this, you get it is equals to 529. Use your calculator to compute 0.53 meters squared. So that is the surface area of the frustum. Part B, we look at the capacity of the tank in liters. Capacity of the tank in liters. So capacity is the same as volume, and to get the volume, we say the volume of a cone is given by a that. Volume of a cone is given by a that pi r h, pi r squared. This is squared. So that is the volume. So to get the volume of the tank, it is the volume of the whole cone minus the volume of the small cone. So we say volume is equals to a that pi, we use the r squared, then we have pi r, the height of the big cone, then we minus that r squared, the height of the small cone, where we can factor out, here we have pi, so we can factor out pi, that pi, not that pi, and we are left with r of the radius of the big cone multiplied by the height of the big cone minus the radius of the small cone squared and the height of the small cone. So this will give you, it is that multiplied by 22/7 into bracket, then the radius of the big cone is 12 squared, the height is 14.4 multiplied by 14.4, then you minus the radius of the small cone is 6 squared multiplied by 7.2, the height is 7.2, and when you use your calculator, you compute, you'll be able to get 1,900,281 liters. That is to the nearest liter. So that is the capacity of the tank. Use your calculator to work out that. And finally, we are told that on a certain day the tank was filled with water. If the school has 500 students and each student uses an average of 40 liters of water per day, determine the number of days that the students would use the water, and you get your 3 marks. So let's see how many days that the tank will take the student when it is capacity full. So now that we have the volume of the tank, and we are told that there are 500 students, each using 40 liters a day, then we will divide the volume of the capacity of the tank with the number of liters used by the 500 students in a day. So we say number of days is equals to the volume, that is 1,900,281. All this is divided by 500. Each student will use 500 students, each using 40 liters. And using your calculator, you should get approximately 95 days. So it would take the school 95 days to use the tank when it is capacity full. And that is how you work out that question. I hope it is clear. If you have any question, you can always forward it through my WhatsApp number or through my email.